Hello and good day. Welcome to part 221 class. Today we'll be dealing with study session 3 and we'll be addressing administration and decision theory contents. Decision analysis is the modern approach to decision making, both in economics and in business. It can be defined as a logical and quantitative analysis of all the factors influencing a decision. The analysis forces decision makers to assume some active roles in the decision making process. By so doing, they rely more on rules that are consistent with their logic and personal behavior rather than on the mechanical use of a set of formulas and tabulated probabilities. In this study session, we shall take you round the decision analysis process that will build your knowledge in decision making. When you have studied this session, you should be able to take good decisions which must be consistent with the information and preferences of the decision maker. You should also be able to explain certainty and uncertainty in a decision analysis. You also should be able to use the decision of analysis to provide decision making framework based on available information on the business environment, be it a sample information, judgmental information, or a combination of both. Administrative and decision process. The administrative and decision process generally refers to the series of steps, actions, and considerations that are undertaken within an organization or government body to manage administrative tasks and make informed decisions. The art of problem solving and decision making is based on common sense. It is to ensure that better quality decisions are made for approaching problem solutions. There are two ways of approaching problems and obtaining solutions. The two main ways are the analytical thinking and the creative thinking. The analytical thinking seeks to improve on a given situation, while the creative thinking considers the end rather than the means. The above two approaches may be further subdivided into various methods. We have the critical examinations, the brainstorming or group creativity, analogies, morphological approach or attribute listening, heuristic approach. So let's start with the critical examinations. Critical examination is a logical approach which answers questions like what, who, where, how, when, and why. The result of why investigations are supposed to indicate possible alternatives or choices from which an acceptable solution may be derived. Moving to the second one, which is brainstorming. Brainstorming is a method based on two heads are better than one. Brainstorming involves conference techniques by which a group of people attempt to find solution for specified problems by amassing all ideas spontaneously contributed by its members. It is a free thinking meeting. Steps on brainstorming are as follows. We have orientation, consideration, speculation, and recommendation. Moving to the next point, we have analogies. This is the comparison of one thing with another that has similar features. They are of different types. We have the personal analogy, the direct analogy, the symbolic analogy, and the fantasy analogy. Starting with the personal analogy. The personal analogy is putting self in place of an object. Putting self in place of an object. Direct analogy is used to compare things in nature with the situation and use nature's solution to provide a lead to a suitable solution. Symbolic analogy uses objects and impersonal images, while the fantasy analogy, in fantasy analogy, the problem is transformed into a realism of fantasy. Morphological approach or attribute listening. This method looks for the attributes or qualities of the product that is in comparison to the best one. Certainty and uncertainty in decision analysis. Most decision-making situations always involve the choice of one among several alternative actions. The alternative actions and their corresponding payoffs are usually known to the decision maker in advance. A prospective investor choosing one investment from several alternative investment opportunities, or a stock owner determining how many of a certain type of commodity to stock, or a company executive making capital budgeting decisions are some examples of business decision making. They are examples of business decision makers selecting from a multitude of of alternatives. The decision maker, however, does not know which alternative will be best in each case, unless he or she also knows with certainty the values of the economic variables that affect profit. These economic variables are referred to in decision analysis as states of nature, as they represent different events that may occur over which a decision maker has no control over. The states of nature in decision problems are generally denoted by SI, where I takes values from 1, 2, 3, all up to K, where K is the number of different states of nature in a given business and economic environment. It is assumed here that the states of nature are mutually exclusive, so that no two states can be in effect at the same time, and collectively exhaustive, so that all possible states are included within the decision analysis. The alternatives available to the decision maker are denoted by AI, where I takes values from 1, 2, 3 up to n, where n is the number of available alternatives. It is also generally assumed that the alternatives constitute a mutually exclusive, collectively exhaustive set. When the state of nature Si, whether known or unknown, has no influence on the outcomes of a given alternative, we say that the decision maker is operating under certainty. Otherwise, he or she is operating under uncertainty. Decision making under certainty appears to be simpler than that under uncertainty. Under certainty, the decision maker simply appraises the outcome of each alternative and selects the one that best meets his or her objective. If the number of alternatives is very high, however, even in the absence of uncertainty, the best alternative may be difficult to identify. Let's consider, for example, the problem of a delivery agent who must make 100 deliveries to different residences scattered all over Lagos metropolis. There may literally be thousands of different alternative routes the agent could choose. However, if the agent had only 3 stops to make, he or she could easily find the least cost route. This decision making under uncertainty is always complicated. It is the probability theory and mathematical expectations that offer tools for establishing logical procedures for selecting the best decision alternatives. Though statistics provides the structure for reaching the decision maker has to inject his or her intuition and knowledge of the problem into the decision making framework so as to arrive at the decision that is both theoretically justifiable and intuitively appealing. A good theoretical framework and common sense approach are both essential ingredients for decision making under uncertainty. To understand these concepts, consider an investor wishing to invest 100,000 in one of the three possible investment alternatives A, B, C. Investment A is a savings plan with returns of 6% annual interest. Investment B is a government bond with 4.5% annual interest. Investments A and B involve no risks. Investment C consists of shares of mutual fund with a wide diversity of available holdings from the security market. The annual return from an investment in C depends on the uncertain behavior of the mutual fund with a wide diversity of available holdings from the security market. The annual return from an investment C depends on the uncertain behavior of the mutual fund under varying economic conditions. The investors available actions. AI, where I takes values from 1 to 4, are as follows. A1, do not invest. A2, select investment A, the one with the 6% bank savings plan, the 6% annual interest. A3, select investment B, the government bond with 5%, 4.5% interest. And A4, select investment C, the uncertain mutual fund. Observe that actions A1 to A3 do not involve uncertainty, as the outcomes associated with them do not depend on uncertain market conditions. Observe also that action A2 dominates action A1 and A3. In addition, action A1 is clearly inferior to the risk-free positive growth investment alternatives. A2 and A3, as it provides for no growth of the principal amount. Action A is associated with an uncertain outcome that, depending on the state of the economy, may produce either a negative return or a positive return. Thus, there exists no apparent dominance relationship between action A4 and action A2, the best among the actions involving no uncertainty. Analysis of the decision problem. In problems involving choices from many alternatives, one must identify all the actions that may be taken and all the states of nature whose occurrence may influence decisions. The action to take none of the listed alternatives whose outcome is known with certainty may also be included in the list of actions. Associated with each action is a list of payoffs. If an action does not involve risks, the payoff will be the same no matter which state of nature occurs. The payoffs associated with each possible outcome is a decision problem in a decision problem should be listed in a payoff table. A payoff table is defined as a listing in tabular form of the value payoffs associated with all possible actions under every state of nature in a decision problem. The payoff table is usually displayed in grid form with the states of nature indicated in the columns and the actions in the rows. If the actions are labeled A1, A2, all up to AN, and the states of nature are labeled S1, S2 up to SK, a payable table for a decision problem appears as shown in the table below. You will see and understand that better in the live class. Note that a payoff is entered in each of the NK cells of the payoff table, one for the payoff associated with each action under every possible state of nature. Expected monetary value decisions. A decision-making procedure which employs both the payoff table and prior probabilities associated with the states of nature to arrive at a decision is referred to as the expected monetary value decision procedure. Note that by prior probability, we mean probabilities representing the chances of occurrence of the identifiable states of nature in a decision problem prior to gathering any sample information. The expected monetary value decision refers to the selection of available actions based on either the expected opportunity loss or the expected profit of the action. Decision makers are generally interested in the optimal monetary value decisions. The optical expected monetary value decision involves the selection of the action associated with the minimum expected opportunity loss or the actions associated with the maximum expected profit, depending on the objective of the decision maker. The concept of expected monetary value applies a mathematical expectation where opportunity loss or profit is the random variable and the prior probabilities represent the probability distribution associated with the random variable. The expected opportunity loss is computed as shown, which we will of course see in the live class, where the formula is expected value of Li minus expected value of Aij multiplied by Lij multiplied by P into Sj, where Lij is the opportunity loss of selecting action A given that the state of nature S occurs, and Ps is the prior probability assigned to the state of nature Sj. The expected profit for each action is computed in a similar way as shown. The expected profit, which is expected value of pi I, is equal to expected value of Aii multiplied by pi ij multiplied by P into Sj, where pi ij represents profits for selecting action A. We'll deal with more examples in the live class. Thank you.